In this tutorial, we're going to take a look at references in C++. I think it's probably going to take us a couple of tutorials at least to properly get through this, but we'll start here. So let's say we've got an integer here, let's say int value 1, and we set it equal to maybe 8. Let's create an int value 2 and set that equal to value 1. And let's change value 2 to 10. So we've got two integers here, value 1 set equal to 8, value 2 which is set equal to whatever was in value 1 at this point, and then we've changed value 2 to have a 10 in it. And let's do some couts here. Let's say value 1 and value 1, and let's also output value 2. So this is going to be hopefully what you expect. So if we run this, we've got value 1 is 8, which it always has been, and value 2, it started out as 8 at this point, but now we set it equal to 10, and that doesn't change value 1. But look what happens if we type a ampersand in front of value 2. Now this is nothing to do with pointers. If you work through my previous tutorials, you remember that we use ampersands to get the address of variables. This is a different usage altogether. Let's run this. And what we find is that by changing value 2, we've now changed value 1 as well. The reason for that is when you declare a variable and set it equal to something else, and the variable name has got an ampersand just in front of it, well, you can also put the ampersand with the type like that. That's just an alternate syntax that still works. Let's just run this. But I usually prefer to put it directly before the variable. This is called a reference variable. We say that value 2 is a reference to value 1, and what that means is that value 2 is just another name for value 1. Basically, whatever we do with value 2 is going to happen to value 1 because they're the same variable. If we didn't have this ampersand after the int sign for value 2, we'd be creating another, we'd be allocating another bit of memory to hold an integer. But when we put that ampersand there, we create a reference, and this reference can't hold a new integer. It can only act as a synonym for an existing variable. So we could do this with strings or doubles or whatever you like, absolutely anything. Reference variables just create aliases to existing variables, and we can use those aliases to change whatever value is in the original variable. There's only one bit of memory here that's actually been allocated to hold an int, and that happened when we did this. This is merely a synonym for this. It's a reference to value 1. Now that can be particularly useful when you want to create a function that changes the value of something, and for some reason you don't want to just use a return value there. So let's say we've got a function here. Let's say void change something. Let's make it take we'll have a string, let's say string. In fact, no, on second thoughts, let's not do that. Let's have a double. Let's say double value. And in there, I'm going to do value equals 123.4. So now down here, let's create a double. So double, I'll call it value again, and bear in mind that this value and this value are not the same thing, they're two different variables. Let's set that equal to 4.321. Let's call change something value, and let's do cout on value like this. So let's run this and see what happens. So it says that value here is equal to 4.321. Now the reason for that is you might guess if you've seen my previous tutorials. This is a completely different variable to this. this is a new double variable. It's just that when we do this, we're taking this value and putting it into this. That's all, we're copying the value, but the two variables are different. So then when we change the value stored in this variable, it doesn't affect the value that's stored in this variable. These are two separate variables. The only connection here is that we're taking that value, putting it in there, and then we're putting that value in here. So at this point, if I did a C out, it would say value is 4.321, but then I can change this one and it's not going to have any effect on this. But that's very different if we change this to a reference variable. So now if I run the program, and you see this says 4.321 down here, which matches this, but now if I run this program, it's 123.4, which is the value that we assigned it in this function. And that's because now this isn't a new double variable, it's only a reference to an existing variable, and it becomes a reference to this variable here when we pass it in here. We're assigning this reference to point at this value. So references are quite like pointers. Really, it's just that the syntax of working with references is a lot simpler than with pointers. Nevertheless, often we do need pointers because they allow us to do various things that we can't do with references. But if you can use a reference, it's simpler to use that than to use a pointer. So again, if you're just watching these videos, it's going to be natural to get completely lost. But I'd recommend practicing this. So declare a reference variable like this and check that you can use the reference to change the original variable. And then declare a function and check that you can declare a function that takes a reference variable and use that function to change the value of a variable that you pass in. Just have a go at that and see what happens. And as I've said before, you can't expect to feel completely comfortable with this, even if you do these exercises. But later on, we're going to write some complete programs. And after that, or even now, certainly, if you try to write your own programs, that's when you will become comfortable with the syntax. Ultimately, there's no substitute for trying to invent your own programs. But of course, when you only know minimal syntax, it's difficult to do that. But the sooner you start writing your own stuff, just making stuff up, inventing stuff and writing it, the sooner you'll start to become comfortable with this stuff, which at first seems very complicated and confusing. We'll leave it there for this tutorial, and until next time, happy coding.